Hi everybody, and welcome to this tutorial where we're going to see more about how to create animations and 3D models that are kind of appealing and more like the real thing when it comes to modeling and simulating something in SIMIO. In general, the capabilities of SIMIO to create ultra-realistic environments are not great, but we can approximate them in order to be able to communicate better what we are talking about. So the example we take now is very simple. We have a source, a server and a sink, and the server is essentially an excavator, which is very similar in fact to what we are going to do in your assignment this year. So the server is an excavator which is processing some kind of entities, which are rocks, which are going to be placed into a sink. So now on screen you see the source, the server and the sink. And now, first of all, we are going to apply a symbol, a relevant symbol, in order to communicate that this server is in fact an excavator. So there are many symbols you can choose from. And in fact, you probably noticed there is a symbol just for this excavator. So now, it's already looking a little bit better than it was before. Before it was pretty boring, if you ask me. So we can do quite a few things with this object. We can change the color, we can change it to green for instance, but also we can try to orient it in the right way. So now we want, for instance, to turn it 90 degrees. We can do that. We click on the server, on this object, we go under General in the properties, and we go under Physical Characteristics. And we can change what is called the yaw, which is the angle by which this object is inserted into the SIMIO environment. So then we can also make so that all the entities are directed towards the scoop of this particular excavator. So we can move nodes and paths in order to make possible to visualize the process in a more realistic way. So now you see the green triangles moving from the source to the server to the sink, and it looks like there is some material being processed by the excavator. And you can also move around all the different cues, which are these green lines that you see on screen. So the green lines can be moved back and forth, they can be turned, they can also be made longer, they can assume a zigzag shape as much as you want. So you can move them in order to create a simulation which is as realistic as possible, in fact. You probably notice that sometimes the excavator is green and sometimes is yellow. Why is that? Because every object that you import, especially servers, they have different type of states. So sometimes the object is off shift, sometimes it's processing, sometimes it's failed, and you can give different colors and different appearances to this particular server depending on the state it is. So in this case we can, for instance, change the color for the processing state. So now we select the processing state and we select red instead as the color for it. So now when the machine is idle it's green, and when the machine is processing is red. So the excavator has two states and the colors they represent these states. So now I bring the server and the sink a little bit closer in order to see the CAD model a little bit bigger, because we are going to introduce an entity, the rock, and we are going to give this entity also a CAD model which is representative, a 3D model which is representative. And we do that not by applying an existing symbol from the SIMIO library, but by importing a symbol that we have created or downloaded. All the files that you have seen on screen, they have a particular format called .obj, which is the only format that SIMIO recognizes. So now you have this pop-up window with different import options. You can select if to import the material or not very important for this item, which is just one single object. And then you can see the object in 2D or 3D. 3D is very good in order to understand the size of it and to understand its orientation. You can change the properties, how big is the object in this window here, with all the values referred to meters, and you see this human giving you some references, and then you can rotate the object in order that it appears correctly inside the simulation, but you can rotate it even after that. So now we have imported our rock here, and we can give it a color which is more like a rock, like some grayish color here. So when we run the simulation, we see a rock moving towards the excavator turning red, and eventually passing through the rock to the sink. So we can move, even when we run the simulation, the different cues around in order to create something that looks more like the real thing, as I said, even if we are pretty still far from the real thing. So what to do now? How can we make it even better? So we can, for instance, import a better model for the excavator. And SIMIO allows you to import 3D models from the Google SketchUp warehouse. In fact, in this particular case, there are different products that you can search with the name excavator. I didn't find anything very useful the first time I've tried, so well, for now we leave it like that. But there are of course many more models you can download. Okay, you can even create with Autodesk Inventor and export as OBJ file. Now we can think about placing all the simulation on a map, on a particular location. So we can activate a map by this. There are two different options. One is the road layout, which is the one that you see here, and then there is one that is more like the satellite view of it. So where are we now? So this is set to be close to the SIMIO headquarters in the US. So if you're wondering where you end up, okay, this is the headquarters of SIMIO. So this is the road layout. It can be pretty good, for instance, if you have to run a simulation related to traffic. That's not bad. But you can also move to a more realistic satellite image. You can scale up things up and down, but of course it won't look very good when overlaid on a map. What we can do, we can move things in the right location. For instance, we can select everything, pushing Control and dragging and dropping, so we can move things all together. And of course, as I said, you can also get the satellite view in order to see exactly where you are and move your simulation in a better location. So now we place ourselves in this random parking slot close to SIMIO headquarters. And we are essentially looking at the simulation here. So what we can do also is to eliminate the grids that are overlaying the picture, the satellite picture, because they don't look really great. We can move to 3D, and of course the buildings are not three-dimensional here, so we can be happy enough to have this plain view. If you click auto rotate, the camera will auto rotate, in fact, and will show you the scene rotating 360 degrees along across the scene centered on the excavator. If you click walk, you have a different type of experience. It feels like you are walking in the environment. But of course, this doesn't look very great right now. We can improve it by adding a skybox. So a skybox allows you to fill up this white background with a picture which is much nicer. So you can select like a mountains, and you will get a scene which is going to look more like real in a way. And you can import different skyboxes if you want. So you can also then use the auto rotate and the walk function in order to record some videos, for instance. Or you can try to improve your model even better. So what can we do now? So I don't want to, for instance, move this particular simulation to another location. I can change the latitude and longitude, for instance. Or I can eliminate the map view and add only, for instance, a background image which is more representative at this particular location that I selected. So you can add and you can add a background color to your scene, and you can change the color as much as you want. So the background color is a very solid color, but you can change the texture if you like. So you can also place additional symbols in order to create a more realistic and engaging scene. For instance, I can create, I don't know, 2 factories. I take the symbols of these factories and I move them inside my facility view. So I put a factory, let's say here on the right hand side of my excavator, and I put another type of factory symbol above it. So in this case, I try to create something which, is a little bit more engaging, is a little more cool to look at. I can also add some additional stuff. Let's say that I want to add some plants. just because I want to do that. And you can import, for instance, the symbol of a plant from the standard library. I can make it bigger and duplicate it. Ctrl V, Ctrl C, Ctrl V, in fact, copy and paste. And then you can click to walk and try to experience the scene that you have just created. So now this looks a little bit less boring than what we had in the very first beginning with the boxes and arrows. We can also eliminate quite a few things, and first of all we can also change the type of lighting in this particular scene. We can have direct and indirect shadows. The direct shadows, they look a little bit cooler, in fact, and they replicate and they try to simulate the light from the sun. Diffuse shadows are better for interiors. You can also eliminate all the graphical items that you don't want to see in the scene, that are disturbing kind of the scene in a way. You can remove links, notes, labels, and so on and so on and so on. So you can do quite a lot of things inside the simulation to make it more realistic. So now it looks decent, but we can do, of course, much better. You can really try to unleash your creativity when trying to make things even better. Something I've been quite successful with in recent times is to import, for instance, files from Blender, which is a particular CAD application, so to create these terrains, for instance, in an OBJ file, from an OBJ file into SIMIO, and modeling, for instance, a quarry or a mining site. So there are many more things inside the animation, the view ribbon, the visibility ribbon. And inside the animation ribbon you find quite a lot of different labels and charts, and we already saw how to visualize them and how to add them to the facility view. So we can also go back to the drawing view and adding floating labels and floor labels if you want, and we can try to do it. Of course, now that you are looking at my screen, I'm clicking on floating label and floor label quite a lot and nothing appears. Always remind that you have always to check if you gave visibility to the items that you just placed on this view. So now when I give a visibility to what I just placed, I notice that I placed quite a lot of them. And for instance, I take this label and I write excavator in order just to show that, okay, this is an excavator which is going to be used for this particular purpose, and so on and so on. There is also another type of label, which is the floor label. But one problem with it is that first of all it's difficult to use, and then it disappears if you give the floor, the ground, a particular color. Even if you change the background color of this type of floor label, this is not going to look very good. So I totally suggest you, okay, not use this particular type of label in your simulation, because there's a very big risk that every time you add something, this just disappears for some reason. So now I want to do something really weird. I want to position my excavator on the roof of this factory that I just added to my simulation. So I have to lift it up and move it a little bit back in order to set it on the roof of the excavator. If you go on the physical characteristics, you can change the height of the excavator to actually come at the same height of the factory. Now we don't have exact values of what the height of the factory is, so we have to go and do a little bit of trial and error things here. So I'm been successful in moving up the excavator by changing the physical characteristics of my excavator. Now moving across the X and Epsilon axis, no, actually the X and Z axis in SIMIO, I can position it to be, in fact, perpendicular to the roof. And now I can go again into the general physical characteristic properties and adjust the Epsilon axis, which is slightly weirdly representing the height of something, until I get a number which is satisfactory enough in order to represent the fact that the excavator is now on this particular roof. So now I'm changing and I'm playing a little bit with the numbers. When I find a number which is satisfying enough, I can leave it there. We leave 7.4 now, and now we have our excavator exactly on the roof, and our simulation is now running with these particular characteristics. We can do more, we can duplicate plans, we can introduce more items, etc. So here is very much up to your creativity, and You can add texture, for instance, to the buildings in order to make them to look better than just gray blocks. You can select a particular texture. For instance, we can take this rusty thing here, rusty peel, and we add it to as a texture to the first building, and then we take instead let's say this gravel thing as a texture of the second building. So let's try out things and play with stuff as much as you can. These aesthetic features are very important parts of the model because they make people to understand what's going on even if they don't have technical skills on simulations. Now let's have a look how to create different symbols for the same entity. So let's say that we put a source, we place a source in the facility view. The source is generating customers who are going towards a server and then are directed towards a sink. So this is a very typical linear flow. Source, server and sink, and the customers that are traveling through following some paths that I'm drawing now on the window. So now let's click on customer and try to apply a symbol. There are different types of symbols for people, and the difference between them is that some are static and some are animated. And the animated ones, we have quite some interesting capabilities that I want to show you now. So let's apply one symbol now and let's visualize it in 3D. So now you see the process. I try to make it smaller so you can see it a little bit bigger on your screen. And when you click on play, the simulation runs pretty quick. In fact, right now we have to slow it down for a second, and you can see this woman moving inside the simulation. Something that you probably notice is how this person, this woman, is moving in a very strange way, in a very weird way inside the simulation. We can modify these parameters quite easily. We can go under animation and we can change the default animation action to be nothing, for instance. So now the person is no longer animated, is kind of static and is moving through the system without doing any type of gesture or anything. But of course, having the default animation action or be set on moving and idle gives a little bit more feeling to the simulation itself. But now I want to show you something else. We can in fact add more symbols to the same entity. So this customer can represent a woman, but can represent, for instance, an elderly woman, or can represent a young boy, or can represent yet another type of woman, another type of persona. So we can create more symbols, and in this case we have to generate them, and under the animation ribbon select random symbol enable, so random symbol to be true. So we can generate several symbols for the same entity, and these are randomly generated by SIMIO in order to give, as said, more realism to the simulation. This is different from what we've done in the past with multiple entities. In this case, these symbols are randomly generated, but the logic of this customer is exactly the same. So the properties, the processing time of the server is not changing because we change the symbol which is created by the animation. So in this case we select 4 symbols, for instance, and we let the simulation to run to provide this richer look and feel relation to the simulation. Funny enough, people in SIMIO do not just walk, they can do quite a lot of different things. So we have different types of symbols and animations, in fact. So what you see on the screen is the list of different activities and animations that you can add to your particular simulation. So if you look back in SIMIO, you find this current animation index property, and you can use the numbers that I just displayed on screen in order to say to SIMIO exactly what type of animation you want your humans to perform. In this case, people are running, but we can change that. And we, for instance, select the animation number, let's say 17, and see people moving across the simulation sitting down. So you can in fact have different animations related to different servers in order to create this more immersive process environment. So now let's have a look to some animation properties that are very important to your assignment. So let's place a source and a sink in your simulation model, and a vehicle which is traveling between the source and the sink, delivering entities. So this is called truck. So now we place some transfer nodes. So transfer nodes, they are used in order to create a particular path, which is not just a straight line, representing where this truck is going in order to deliver this material. This could be placed, for instance, above a road or above a path, which is predetermined, or simply to follow some geographical features. In this model, these segments will represent different power requirements for the truck. So when the truck is traveling on path number 1, it needs a certain amount of power. On path number 2, between transfer node 1 and 2, yet some other amount of power, and so on and so on. Of course, to make the model to run, we need to set some parameters, and we already know we need to select the destination type to be specific, and the entities will go to the sink, and we need to say that these entities are going to run on a transporter. And the transporter will dwell until it's full, so it will have a capacity of 5, and we'll wait until we have 5 entities before moving to the sink. So this is all stuff that we know from vehicle modeling in previous courses and in previous applications. What is interesting now is that we want to model these power requirements. So we want to associate a state to every segment that we have defined in this map. We go on the definitions now and we click on states. We create a real state called power. So this is the power needed by the truck to move along the different segments. And consider that the different power requirements can be related to the road going up and down, and so on and so on. Or to the fact the truck is loaded or the truck is empty. So what we're going to do now is that before entering every path, we assign a state, which is a power, and we assign to this state a specific number, a specific value. So we select power as the state variable name, and the new value for path number 1 is 70 or 78. So for path number 2, we repeat the process. So when entering path number 2, which is a different types of road surface, or it has a different inclination, we set yet another value of the power requirement, and we do that for path number 3, as you see on screen, and we repeat this operation for all the relevant segments that we might have. So in this particular case, we have 7 segments, but they can be considerably more. And you can model a particular path that a truck or any vehicle is doing by using as many transfer nodes as possible. Now I'm continuing coding in the different state assignments. On entering, I add state variable name power, and I give a new value. So let's close it here, and now we have a last one. Again, power, new value. A bit boring when you have a lot of transfer nodes, but let's run the model now. So what is happening is that every time the vehicle goes through a certain path, it is assigned this power requirement. It's not visible anywhere. So we can do some changes in this model to make it more visible. First of all, we can change the color of the truck, because so we see the entities when they are transported. And I change it to yellow for the particular action being busy and being transporting things. And then I also want to show you something else. I want to show you that under animation, you can attach a dynamic label text to the track itself, where you can select power and you can visualize it when running through the system. So now when we click play, you see there is a small counter below the vehicle. So the counter below the vehicle represents the power that we just inserted as a new value for that particular state. So we go a little bit slower now, so you can see that the number is changing. Every time we enter a path, the number is updated. So we can use a status plot, for instance, a two-dimensional plot, in order to display this power cycle, as we can call it. First of all, I change the text scale. I want to represent what is happening every 5 minutes. And then, of course, I change the title of this graph to power, and the epsilon axis will be in kilowatt. And when I click run, now, in a second, I have to add the expression to this particular plot. So we select power here in the expression property of the plot. I can run it now, and as you see, I create a curve, a pretty interesting curve, in fact, which is displaying how power is changing when running around this particular track. So there is a small mistake here. When the machine stops at source 1, you see the number 54 is displayed below the track. because we had to say that when exiting path number 7, the power requirement goes to 0, because here we just wait for material to be delivered on the truck. So here we change it down to power, we select power, and we select the new value of 0. And this happens when before exiting path number 7. So we run the simulation again. Now you see it's 0. And when running around the circuit, the power requirements change. When we stop to load material, it goes down to 0. And we can visualize in this way a pretty interesting curve, in fact.